Welcome back to another episode of Tech Talk Today. I'm your host, and today we're diving into the intriguing world of network communication. We'll be exploring the differences between Voip, UDP, and TCP, and how each of these technologies shapes our digital experiences. So grab your headphones, get comfortable, and let's jump right in. Let's start with Voip, which stands for Voice over Internet Protocol. This is the technology that allows us to make voice calls over the internet instead of using traditional phone lines. A key player in Voip is UDP, or User Datagram Protocol. You might be asking yourself why UDP is often chosen over TCP, which is the more common protocol for data transmission. The answer lies in a trade-off between reliability and delay. TCP, or Transmission Control Protocol, is built for reliability. It ensures that all packets of data sent are received and in the correct order. However, this reliability can introduce delays. If a packet gets lost, TCP will attempt to retransmit it, which is great for things like web pages or file transfers where every piece of data needs to arrive intact. But in Voip, where timing is everything, that reliability can actually slow things down. Imagine you're on a call, and there's a delay because the system is trying to resend a lost packet. By the time that packet arrives, the moment has passed, and the conversation moves on without it. In Voip, if a packet is lost, the system fills that silence, and you might find yourself asking, "Could you repeat that? I missed a bit." The retries happen at the human level, not the technical one. Now, let's dig a bit deeper into network delays. When we discuss delays, we often refer to queuing delays, which can vary greatly depending on the network's capacity. If a system is close to its maximum capacity, long queues can form quickly, leading to significant delays. This variability can be frustrating, especially when you rely on real-time communication. Another important aspect is the shared nature of network resources. In a cloud environment, for example, multiple customers are using the same network links and switches. If one customer is consuming a lot of resources, it can negatively affect the performance of others. This is often called the noisy neighbor problem. So while you're trying to enjoy a smooth VoIP call, someone else's heavy usage might be causing delays. So how do we tackle these unpredictable delays? One effective method is to measure response times and their variability, often referred to as jitter. By automatically adjusting timeouts based on observed response times, applications can better handle the inherent variability of network conditions. For instance, systems like Akka and Cassandra use a technique called a phi accrual failure detector to manage these challenges. You might wonder why we can't just ensure reliability at the hardware level. This brings us to a comparison between traditional fixed-line phone networks and modern data center networks. Traditional phone networks are designed for reliability, allocating guaranteed bandwidth for calls, which minimizes delays, a process known as circuit switching. On the other hand, most internet traffic uses packet switching, which is more efficient for bursty data, but can lead to unpredictable delays due to queuing. Each packet competes for bandwidth, resulting in varying delays. While circuit switching is excellent for consistent audio or video calls, it doesn't handle the diverse and unpredictable nature of internet traffic as effectively. Now, you might be asking, why not just use circuit switching for everything? The answer lies in efficiency. Circuit switching can waste network capacity. If you reserve a fixed amount of bandwidth for a call, that bandwidth is unavailable for other uses, even if the call isn't actively using it. Packet switching, however, allows for dynamic bandwidth allocation, maximizing the use of available resources. This dynamic allocation is particularly important for applications that don't have a constant bandwidth requirement, like web browsing or file transfers. TCP adapts the rate of data transfer to match the available network capacity, which is crucial for efficient internet usage. Unfortunately, The technology we have today doesn't allow for guaranteed delays or reliability in networks. We have to operate under the assumption that network congestion and unbounded delays can occur. This means that timeout values for applications need to be determined experimentally, as there isn't a one-size-fits-all solution. Let's shift gears a bit and discuss the importance of timing in networked applications. Accurate timing is essential for various functions, such as determining if a request has timed out or measuring response times. However, due to the variable delays in the network, it can be challenging to pinpoint exactly when a message was sent versus when it was received. Each machine on the network has its own clock, which can differ slightly in accuracy. Synchronizing these clocks is crucial, and one common method is the Network Time Protocol, or NTP, which adjusts computer clocks based on time reported by servers. Even with synchronization, discrepancies in timing can still occur. In conclusion, the world of network communication is a complex interplay of technology, efficiency, and timing. Voip utilizes UDP to prioritize real-time communication over reliability, while TCP ensures accurate data transmission, albeit with potential delays. Understanding these differences is vital for anyone working with networked applications or simply trying to navigate their digital experiences. As we explore this landscape, it's important to recognize that variable delays are not just a technical hurdle. They represent a cost-benefit trade-off that influences how we design and use our networks. So the next time you're on a call or streaming a video, take a moment to appreciate the intricate dance of packets and protocols that makes it all possible. Thanks for tuning in to this episode of Tech Talk Today. If you enjoyed our discussion or have any questions, don't hesitate to reach out. Until next time, keep exploring the tech world around you.